Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 11 of a unit electric charges and fields. In previous classes we have been discuss about the Gauss's law and we are discussing the applications of the Gauss's law. We have already discussed the one application, that is the electric to find out the electric field due to point charge, sphere, and conducting spheres and non-conducting spheres. Today we are going to discuss about the electric field. Electric field due to a uniformly charged infinite plane sheet. We are going to discuss the electric field due to this. So let's begin with this class. Let's suppose a certain sheet is there and it has been given a charge. First we are going to discuss electric field due to non-conducting infinite plane sheet. So while I say non-conducting, things would look like this. Let's say this is the sheet, and on this surface, as you can see that there are this sheet having a two surfaces. One is this surface and another one is the second surface. It is the back end side of this. So it should look something like this. It's a back end surface. If I have been given a charge q here, something like this. If I have been given a charge, let's say q at a here, then this electric field due to this charge would be available in this direction as well as in this direction. But charge cannot move from this surface to a backend side. This should be considered. Do you understand what I mean? If I have been given a charge on any one of the side, then charge would be available on that side only, because as its name suggests, it is a non-conducting. But energy does not have any boundation. So electric field is a one kind of energy only. Yes, so electric field will be available on both the directions. Now what would be the situation? Let's reconsider this, that I have given a charge q to a infinite plane sheet which is a non-conducting one. This I have seen a cross sectional. I have drawn the cross sectional area of this, and I have considered one Gaussian surface. For this. That Gaussian surface, its name is pillbox. It's a cube kind of thing, but you cannot call it as a cube because it is not a perfect cube, but it is a cube kind of thing, and we technically call it as a pillbox. So this here it is having a charges. Here this is having a charges, and if I draw a diagram as this surface and this surface, for this electric field would be moving in this direction. For this surface, electric field will be moving in this direction. Okay, are you done with this? Now I need to find out electric field due to this sheet. What should I do? According to the Gauss law, what I can do is flux should be is equals to q enclosed by epsilon naught, as well as flux should be is equals to E dot A. So here I am having a two surfaces. First is this. Here area vector would be in this direction and theta would be a 0 degree. Here even electric field will be in this direction, area vector would be in this direction, and theta would be equals to 0 degree. So here this is EA, and one more EA would be there. So that comes to EA plus EA, which give me a 2 EA, and that would be equals to q enclosed by epsilon naught. Now I know that sigma should be is equals to q by a. So q I can write as in sigma into a divided by epsilon naught, that I have written here. Are you done with this? And if electric field, if area vector has been cancelled, then electric field due to thin non-conducting and infinite sheet is sigma by 2 epsilon naught. As I know that electric field is a vector, so if I write it as a vectorically, it's an E should be is equals to sigma by 2 epsilon naught into unit vector, where n is a unit vector which is normal to the plane sheet, And in outward direction, when I considered outward direction, I consider that sigma is positive. That means I have provided a positive amount of charge to the thin infinite plane sheet. That E is directed away from the plate if sigma is positive, and it is towards the plate. It is the towards the plate if sigma is negative. So let's look at the situations. Let's say this is the sheet and given a charge as a positive. So for this region, electric field will be in this region. We are here discussing about the non-conducting sheet. E1 should be is equals to sigma by 2 epsilon naught. Even in this direction, let's look, this is moving away or this is directed away as the charges are positive. This electric field will be sigma by 2 epsilon naught, and this is the direction moving away or radially outward. Now let's look at the new situation. If charges given is negative or if sigma is negative, the things would look like this. Then if I write an electric field, the value would remain the same. It's in sigma by 2 epsilon, but direction will reverse. Now it should be moving towards the plate. It should move towards the plate. If I write an electric field at here, the data would remain the same. That means the magnitude remains the same, but electric field will be in this direction. Please do remember these things. Is it done? Are you sure? Yes. One very important case is electric field is independent of x, that is distance from the plane sheet. Now you need to redraw this. What was the electric field? It's a sigma by epsilon naught. Here it is sigma by epsilon naught. If I replace even a sigma, it would be an q by a into epsilon naught. Q by a upon epsilon naught. Which means this is not dependent on the distance from the plate. Yes, this is not dependent on anyhow with the time. That means this is a source of uniform electric field. I hope you understand the meaning of uniform electric field, that the direction and magnitude of electric field is not varying, it is the fixed. That is the source of uniform electric field. There are very rare cases where electric field provided by certain sources are uniform. It is one of the same. Yes, it is one of the same. So have you done with this? This does not depend on the distance from the plates. In spheres it would be dependent because the relations were E is equals to K into Q by R square. So as soon as the distance is increases, the value of an electric field will be decreases. Are you sure? Yes. So let's move on. This, if they have given that this is electric field and this is distance x, how it should look like? That's a sigma by 2 epsilon naught. Sorry, how it should be look alike? Yes, it is independent of the distance, and as it is a positive one, I should look like this. Are you sure? Yes, this is all the things. This were all the things for non-conducting infinite sheet. Now let's say one more case. Suppose you are having an uniformly charged but conducting, look at this, it's in conducting infinite plane sheet. Now what would be the situation? So let's redraw this. Suppose this is the plane sheet, this is side 1. If I draw the side 2, this is side 2. I have given a charges at here, as well as on the back of the side as well as, so that means that on this side also charges are there. So if I have been given a charges over here as well, this is q, let's say even this is q, or you can write it in a terms of sigma as well. Let's say this is plus sigma, this is plus sigma. This is the situation that I have drawn on this thin surface, that charges are there on both the surface. I can draw only on one side because second is on the back end side, so it is not possible to draw it a two dimensionally, but you can visualize it, I'm sure for this. So now what would be the situation? Let's say I need to find out electric field at this point, electric field at this point. What I need to do, I need to draw a Gaussian surface and I need to cover this locations in the Gaussian surface. Which one is the preferred Gaussian surface? That is the pillbox. So I make a pillbox. Now direction of electric field at this location and this location. Direction of electric field at location E. This is positive charge. For positive charges, electric field should be moving outward from the surface. So this is the direction. Area vector would be in this direction. Here the theta angle between electric field and area vector, it is a 0. Here this is the direction of electric field. Here this is the direction of area vector. Now again the theta would be a 0. So the situation would be look something like this. You are having flux is equals to EA plus EA, which is a 2EA, and you are having a flux which is equals to Q enclosed by of epsilon naught. That means it is twice of sigma A. I have replaced this Q divided by epsilon naught. This is relation number 1, this is relation number 2. Let's compare it. This is the situation. Twice of sigma A should be is equals to 2 into E into A divided by epsilon naught. So if I solve this, area vector, 2 2 has gone. So whatever the remaining thing, it is a sigma by epsilon naught. If I write this according to the vector, it's a sigma by epsilon naught multiplied by unit vector. Again the same thing I will discuss, that if it is a positive charges, electric field would be a sigma by epsilon naught, and direction would be this, it's moving outward. This is E1, this is E2, having same in magnitude but opposite in direction. Both are moving outward. You don't remember like this is positive x, this is negative x. You need to consider that when plate is having a positive charge, direction of electric field will be moving outward. When plate is having a negative of charge, let's look. The electric field having a magnitude will be the same. It would be a sigma by epsilon naught while I'm talking about the conducting sheet. But direction of electric field will be moving inside. This is even, or you can say this is inside. Okay, are you sure? Okay, let's summarize these things. You are having two kind of plates. You are having infinite two kind of infinite sheets. One is the non-conducting, another is the conducting. Let's say one of the plate is given a positive charge. Direction of electric field will be outward to the plate. It's a sigma by 2 epsilon naught. And another plate which is having a negative charge, then this electric field will be sigma by 2 epsilon naught. Even this would be radially inward. This is sigma by 2 epsilon naught. This too, this is, as the charges are positive, it moves radially outward. And as charges are negative, it moves radially inward. I keep repeating these things so that you remember it very carefully. Now let's look at the cases. of a conducting plate. Let's say a conducting plate is there, which is having a positive charge, which is having a positive charge. Now the electric field will be sigma by epsilon naught. Let's look a direction. It is radially outward. Here as well, the direction would be a radially outward and magnitude would remain the same. If plate is having negative charge, then magnitude would remain the same. Magnitude would remain the same. But direction would be radially inward. This is radially outward, and this would be the radially inward. One is radially outward, other is the radially inward. Are you sure? Now can you do this? Can you do this? Are you sure? So let's check certain questions and numericals. Let's begin. One of the MCQ. Read it carefully. Do it on your own. What the data has given is, they have given that electric field intensity at a point due to uniformly charged infinite plane sheet is, they are talking about the infinite plane sheet. What would be the situation? That is directly proportional to the distance. Does it depend on the distance? No. So this would be the false. That is inversely proportional to the distance. This is false. Independent of the distance of the point. Yes, this is correct. And let's look at the fourth option as well. Directly proportional to the square of the distance. No, this is incorrect. This would be the correct answer. Yes. Let's go through one more question. For a uniformly charged plane sheet, the electric intensity at a point is, now very good question. Look at this. We have talked about that there are two sheets. One is the conducting, another is the non-conducting. But what can I do if they have not mentioned that whether it is a conducting sheet or non-conducting sheet? Like this is the case, uniformly charged plane sheet. They have not mentioned whether it is a conducting plate or whether it is a non-conducting plate. So what you need to do is, non-conducting is to be considered as a by default. This is the case in spheres as well, that you need to consider non-conducting things. You need to consider non-conducting things as a default. So when you consider a uniformly charged plane sheet, that means you need to consider a non-conducting sheet. Now again go through a question once. They have asked that for a uniformly charged plane sheet, the electric intensity at point, what is it? It's a sigma by 2 epsilon naught. Yes, you are correct. Have you done with this? So do remember these things. Do remember these things, that when they do not mention that whether it is a conducting or non-conducting, you need to consider them as a non-conducting by default. But if they have mentioned conducting, okay, well done, go for it. Are you okay with this? Is there any doubts? No? So can we move to the numericals? Can we? Okay, let's begin. Let's say what the data is, that this is one infinite sheet, this is another infinite sheet. The surface charge density of this is sigma 1, the surface charge density of this is sigma 2. This is region number 1, this is region number 2 between two plates, and this is region number 3, that is outside, that is right of the sigma 2. You need to find that, find out electric field in region R1, R2 and R3. This is the requirement. You need to find out electric field in different regions. Okay, what could I do? First thing, they have not mentioned that this are the conducting or non-conducting. So what you will consider, they have not mentioned about conducting or non-conducting. You should think like this. So you need to consider. So you need to consider non-conducting sheets. Now, one thing for sure is you need to consider a non-conducting sheet. Now, you need to write down the direct electric field and their direction. Let's start with the region number 1. Let's start with the region number 1. This is sigma 1. As it is not having a negative, that means it is having a positive. These two are the positive surface charge density. Now due to this, electric field will be moving outward. This is E1. Again this is positive, so electric field will be moving in this direction. For your reference, can I put a plus sign on this so that things might get clear? These are having a positive charge, so even this is a positive charge. So even if this is positive, direction of electric field will be outward to the surface. So this is direction of electric field 2. What would be the magnitude of E1? Magnitude of E1 would be is equals to sigma 1 by 2 epsilon naught, and magnitude of electric field 2, it is a sigma 2 divided by 2 epsilon naught. Now let's look at the directions of electric field in region 2. I know that this magnitude will remain the same, this will remain the same throughout the region. Now I need to just check it down, just check it about the directions only, because I know the magnitude. Now R2, look at this region is right to this sigma 1. So for moving outward, electric field 1 would look like this. But this sigma 2, now you need to consider that electric field lines should be moving outward from my body. You need to consider your body as a thin conducting infinite sheets or thin non-conducting infinite sheets. This is a case of non-conducting sheets. So what you need to consider is you need to consider a direction such as electric field lines are moving outside the body if your body is having positive charges, and electric field lines should be moving inwards your body if charges are given as a negative. So here the case is of positive. Here your electric field should look alike that electric field lines are moving outside the body. This is your body, so this is the direction of E2. I hope these things are clear. Now come to the region 3. This is the case. What is the sigma 1? It's in positive. So if positive is there, if positive thin sheet is there, you need to consider that electric field lines should be moving outwards from my body. This would be the direction of E1. Even sigma 2 is a positive, even sigma 2 is the positive, and the direction of electric field will look like this. This is E2. Now I need to find out the electric fields. I need to find out electric field in this region. Shall I redraw this? This is sigma 1, this is sigma 2, this is the direction E1 and E2, this is E1, this is E2, and this is the E1 and this is the E2. This is we call as in region 1, this is region 2, and this is region number 3. That is all what we have discussed up till now. Now E net in region 1, look at this. Here both the directions are equal, so you need to add this because this is a vector terminology. So this E net would be equals to sigma 1 by twice of epsilon naught plus sigma 2 by twice of epsilon naught. You need to just add this. Now what would be the E net in region 2? This would be, look at this here, this is positive, this is negative. Let's assume that sigma 1 is greater than sigma 2. So this is equals to sigma 1 by twice of epsilon naught minus of sigma 2 by twice of epsilon naught. And in region 3, E net in region 3, what it would be, both are having the same direction, both the electric fields are having same directions, and if they are having the same directions, they must be added, and if they are going to add up, it will look like this: sigma 1 by twice of epsilon naught plus sigma 2 by twice of epsilon naught. This is the net electric field. What was your answers? Were they same? Yes. Well done. Next, let's go through the next question. Let's now do the things differently. This is plus sigma. This is again an infinite sheet, but minus. They have said that two infinite conducting sheets are given as shown in figure. Find electric field at region 1, region 2 and region 3. They have given that this is region number 1, this is region number 2, this is region number 3. Now let's begin. What is the situation, what the data that all are given, what all things are given. Let's look at first thing. They have given the conducting sheets. So electric field due to first would be a sigma by epsilon naught, and electric field due to a 2 would be a sigma by epsilon naught. So we have done up to the magnitude. Now only the task remain. Would be of direction. So how could I do this? What should be the situation and how could I do this? Let's say this is sigma and it is positive. So for a positive, electric field lines should be moving outward from my body. This is the direction of E1. This is the minus sigma. So for minus sigma, electric field lines should be moving towards my body, with that is inside the body. So if I want an inside kinds of electric field lines, this should move in this direction. This should be going towards the electric field lines. You can say this. Are you sure? Yes. Now what about the region 2? This is plus sigma. So electric field lines moving away from my body. This is away from my body. This is E1. And for minus sigma, it should moving inside the body, but it is at this place. So inside the body will look like this. This is E2. Are you sure? Yes. Now next in region R3, the plus sigma, due to plus sigma, electric field lines will moving outward to this. This is E1. For minus sigma, the electric field line should be moving inwards the plate. This is inwards. This is E2. Now let's talk about the E net. That E net in region R1, direction are opposite to each other. Both the directions are opposite to each other, so they would be subtracted, and this is sigma by epsilon naught minus of sigma by epsilon naught. As these two are having the same numerical value, the answer would be the 0. Next, E net at a region R2. Next is the E net at a region R2. Both are having same directions. So they should be added. Sigma by epsilon naught plus sigma by epsilon naught. This is twice of sigma by epsilon naught. This is the situation. And last, electric field at R3, E net at R3. Here both are having opposite directions. Here both are having an opposite direction. So that is sigma by epsilon naught minus of sigma by epsilon naught, and that will give you a 0. That will give you a 0 and the things will be done. Yes. So in region 1 and 3, net electric field will be a 0, while in region 2, net electric field would be a 2 sigma divided by epsilon naught. Have you done with this? Are you sure? Will you be able to do a one more question? Let's look. Suppose non-conducting sheets are given as shown in figure. Find electric field, and the sheets are, this is plus sigma, this is plus 2 sigma, this is minus of sigma, and you have been given that this is region 1, region 2, region 3, region 4. Now what is first task? First task is to write a magnitude of electric field, E1. It's a non-conducting kind of sheets, so that would be is equals to sigma by 2 epsilon naught. E2, it is by default 2 sigma, so this is 2 sigma by 2 epsilon naught. Don't cut it down, do it as it is. And next E3, it's a minus of sigma, so magnitude would be a sigma by 2 epsilon naught, and nothing will be changed. Have you done up to this? Okay, now let's rush for the directions. In region 1, this is plus, so if it is a positive, what would be the direction? Yes, direction should be moving outward. This is the direction of E1. Next, this is the 2 sigma, even it is a positive, and if it is a positive, the direction would be away from the body, and away from the body would look like this, E2. Next, this is the minus sigma, minus sign would be there, so electric field line should be moving towards that plate, so this should be direction of electric field. This is E3. Have you did this? Are you sure? Have you did this? Are you sure? Okay, so let's look at next region, that is the region number 2, R2. What will be the situation? This is plus sigma, so this would moving like this. This is even, this is plus 2 sigma, but electric field lines would be moving outside the plate, so this should be the direction. Yes, very good. Now this is minus of sigma, so direction of electric field will be moving towards the body. This is E3. Now what would be the situation in region number 3? This is plus sigma, so this is even, this is plus 2 sigma, this is E2. This is minus of sigma, so electric field line should be moving towards the body. This is E3. Now what was the situation in R4, region number 4? For plus, it should be moving like this. This is even. For plus 2 sigma, it is moving like this. This is E2. And for minus, it should moving like this. This is E3. Now you have done up to the directions. Now it's a time for magnitude. So if I write a magnitude, it's an E net due to R1, that would be equal. So look at this, E1 and E2 are in same direction. E1 E1 and E2 are in same direction while E3 is in opposite direction. So you should look like it's a E1 plus E2 minus of E3, as E1 plus E2, this is sigma, this is twice of sigma, so that total would be a 3 sigma minus sigma. This is 3 sigma by 2 epsilon naught minus of sigma by 2 epsilon naught. This is 2 sigma by 2 epsilon naught, which ultimately gives us the sigma by epsilon naught. Are you sure? Now E net due to R2, what is it? Look at this. Here the E1 and E3 both are in same direction while E2 is in opposite direction. So you should write like this, it's an E1 plus E3 minus of E2. Value of E1, it's a sigma by 2 epsilon naught. Value of this E1, it is a sigma by 2 epsilon naught. So if I add this, this is 2 sigma by 2 epsilon naught minus of E2 having a value of 2 sigma by 2 epsilon naught. So that ultimately creates a zero result, a magnitude having a 0 Newton per coulomb. Next E net and R3, look at this, what you should do, it is having both or all those in same direction. So this is E1 plus E2 plus E3. So if I add up this, sigma plus 2 sigma, 3 sigma, 3 sigma plus sigma, it's a 4 sigma. So this is 4 sigma divide by twice of epsilon naught, that will give me a 2 sigma by epsilon naught as a net. And last, E net to the R4, last is the E net to the R4. Now here E1 and E2 are in same direction and E3 would be in opposite direction, so this should be written as E1 plus E2 minus of E3. Now add this to sigma plus 2 sigma, this is 3 sigma minus sigma, so this is 2 sigma by twice of epsilon naught, that is a sigma by epsilon naught. Yes, if you have done this, well done, you did a great job, because so many questions are there, they have been asked from this only, so many. So can you do this? Are you sure? Okay, let's move a certain new category of questions from the same charge source. Let's suppose they have given one of the plate having surface charge density of plus sigma, and in a perpendicular to that, they have given surface a certain charge q. You need to just find electric force acting on the charge q. You need to find out electric force acting on the charge q. Now tell me, how could you do this? Did you remember the electric field? How can we define it? It's an electric field will be the F divided by Q. So from there I know that it is a Q into E. Yes, this is the basic relation. So when and when I need to apply a force like this, it is a Q into E. Do remember one thing. These are the golden points. That this charge will be the mine. When I mean mine, it means I need to consider a body on which force is to be applied. When electric field will be of some other. Do this. Please remember these things, please. But do not write ever in your examination books that charge will be mine and electric field will be of some others. Examiner will not understand what you mean to write. So do not write this in books. This is for you only. So it is F is equals to Q into E. Charge will be mine while the electric field will be of some others. So here what was the case? Who is mine and who is some other? This charge Q is mine and electric field will be due to some others. Here some others will be of the plate. As it is mentioned that find electric force acting on the charge Q, and they have not mentioned anything. They have not mentioned anything about the plate, so I assumed it as a non-conducting. Now I need to write down the F should be is equals to Q into E. This is Q multiplied by sigma by 2 epsilon naught. If they have given that this is given charge Q and it is having an area A, then I can write like Q multiplied by, if I replace the Q, this is Q by A multiplied by twice of epsilon naught. Let's rearrange this. That is Q into Q divided by 2 epsilon naught A. This is the force acting on this charge. So always remember this golden points. F is equals to Q into E. Charge will be mine. Charge will be mine while electric field will be provided by some other. Find this interesting? Yes. Let's do one more question that has been asked by the NEET examinations. Let's say, suppose a certain plate is given and this is non-conducting plate. This is non-conducting plate. One of the thread is there and one bob is there. This bob is having mass m, charge q, and it makes an angle theta with vertical. Now you are given that assume that bob is in equilibrium. Find out tension force in the strings. Now what can I do? Tell me. This is a question having all the previous concepts, even the concepts of 11th class. What would be the situation? Tell me. Let's say this is tension. If this is theta, this must be the theta, then this must be the t cos theta, and this must be the t sin theta. This force would be the q into E. While I am making this direction only because this is a positive charge. Look at this. These are the positive charge. If it is a positive charge, direction of electric field will be moving outward. It is radially outward. And the one more force, it's an mg because bob is having mass m. So the situation would be something like this. This is bob. This is having force q into E. This is having force that is of t sin theta. This is t cos theta. This is mg. As it they say that bob is in equilibrium. What do you mean by equilibrium? When and when we have been said that they are in equilibrium, that means it is having a net force of 0. So if I write like this, it is a t cos theta should be equals to mg, and t sin theta, that should be is equals to q into E. This is relation number 1. This is relation number 2. Let's square this and add up. That means what I mean is t square cos square theta plus t square sin square theta, that will be m square g square plus q square E square. So if I solve this, it would be a t square into bracket cos square theta plus sin square theta, that should be is equals to m square g square plus q square E square. So this is t, because you know that cos square theta plus sin square theta is 1, and if I write this as a t, it should be m square g square plus q square e square. But one very important thing, what is E? What is electric field? This is non-conducting plate, so I need to replace this E. I need to replace this E with the help of sigma by 2 epsilon naught. E is equals to sigma by 2 epsilon naught. Okay, shall I add one more question to this? A same question. Suppose a same diagram were given and you have been asked that find out electric field E. This is the situation. The situation was that this is QE and this was the T sine theta. This would be the T cos theta and this would be the mg. And we have written like this, that T sine theta should be is equals to QE. Let's say this is relation number 1, and T cos theta should be is equals to mg. Let's say this is relation number 2. If I take a ratio of this two, that's a 1 divided by 2, it's a sine theta by cos theta. This is tan theta. That should be is equals to QE by mg. And in this case, E would be is equals to mg multiplied by tan theta divided by q. This could be the given answer. If value of theta is given, you can easily calculate this. So, are you done with this? Any queries? Any doubts? No? Okay. Let's wind it up. This is the second application of Gauss law. We are going to move forward in the next classes with new applications. But before we move to the next classes, please do practice a questions. Practice a lot. This will save us. This will save us. Literally will save us. So let's bye bye. Have a good day. Take care.